Hello everyone. In this session, we are going to discuss problems on centrifugal pump. Theory we have studied, though we have studied, we'll revise the whole thing quickly and then go ahead with the numerical problems. So this diagram gives you nomenclature. Here there is a sump, there is strainer, there is suction pipe, the IF impeller. This is centrifugal pump periphery, scroll casing. So there is a delivery valve, delivery pipe, then this is delivery chamber. The center of the impeller to the sump level, it is a suction head. From IF and impeller to the level up to which the water is delivered is nothing but delivery head. The sum of these two is a suction head. Then to that, if you add the head lost in suction pipe, the head lost in delivery pipe, then that total summation becomes manometric head. So HM manometric head is equal to HS plus head lost in uh, suction pipe, head lost in delivery pipe. Then the discharge that is coming out can be written as pi d1b1 into vf1. So diameter at the inlet, width of the blades at the inlet, velocity of flow. This can be better understood in this diagram. Here I have shown only the impeller in a side elevation. This is shaft of rotation. So this particular diameter is IF an impeller. To that entry is made with a velocity of Vf1. So with the diameter d1 at the entry and with the width b1, the cylindrical surface area becomes pi dp1 multiplied by Vf1 gives the discharge. The same discharge goes out with the width of the blades b2, but the diameter is d2. So pi d2 b2 would be the surface area, but multiplied by the velocity is Vf2. The discharge has to be the same as per continuity equation. So here once again it is written HM, the manometric head, whatever we have said here, plus if you add the head lost in impeller and casing, then we'll be getting total head generated by the pump. So total head or head developed by the impeller per unit weight of the liquid. This is given by VW2 U2 by Z. So H total minus, that is VW2 U2 by Z, minus the losses in impeller and casing, if you do, we'll be getting manometric head. Then these equations we know U1 is equal to pi dn by 60, U2 equal to pi d2n by 60. And generally in the design of centrifugal pump, it is kept that velocity of flow at inlet is equal to velocity of flow at outlet. This is the picture which shows inlet velocity triangle, outlet velocity triangle. The center of rotation is over here. This is the radial direction. This is also a radial direction. Here we have got inlet velocity triangle. So what is made here is radial inflow, in the sense V1 is radial, but as usual we know by relative velocity equation U1 plus VR1 becomes V1. So U1 VR1, angle made by VR1 with the U is the angle of vane, that is theta. Now because V1 is like this, VW2 is VW1 is 0, and then whole of V1 becomes VF1. Then as you come here, outlet velocity triangle, in line with the vane, what goes out is relative velocity. The angle made by the vane will be represented by phi as usual. So 2vr2, if you add u2, what you will be getting is absolute velocity of the jet v2. Now components of v2 in the direction of u2 is known as vw2, and in the direction perpendicular to that is known as vf2, velocity of flow, velocity of whirl. Now u2 being this large, vw2 being this much, so this distance will be written as u2 minus vw2. Then this is anyway vf2. I can write a relation tangent of phi, tan phi, is equal to opposite side, that is vf2, divided by adjacent side, which is u2 minus vw2. This relation will be using often in the calculations or problems. There's one more set of equations. Manometric efficiency given by manometric head developed divided by work done by the impeller. So GHM divided by VW2 U2. Then we have overall efficiency gamma QHM. HM is manometric head divided by shaft power put into impeller. Then this equation, fundamental equation of centrifugal pump, So what is to be carried in this slide is minimum starting speed. N is given by two equations. We should be able to remember these two for solving the problem. We will stop here. We will solve problems in the next